Okay, so first we're going to talk about what a determinant of a square matrix is, which extends from yesterday's topic. I already showed you how to do that, right? So for a 2 by 2 matrix, remember what we're going to do is we're going to take the diagonals. So I'm going to multiply A1, B2, and I'm going to multiply A2, B1, and I'm going to take the difference. That's the determinant of a matrix. So let's go look here at these examples. So the first one, we're going to do 2 times 2 minus negative 3 times 1. And we're going to simplify that. We're going to get 4 minus negative 3 gives us 7. Excellent. And here we're going to have 2 times 2 minus 4 times 1. Here we have 4 minus 4 is 0. Here we have 0 times 4 minus 2 times 3/2. The 2's reduce and we get 0 minus 3 equals negative 3. So these values are permissible. Take a look. We can have a positive, a negative, or 0 value if we're only evaluating for a determinant. So it's really important to understand that this is independent of what we did yesterday. Yesterday we used the determinant to find the inverse. And remember that was 1 over the determinant value for a 2 by 2, and then A and D swapped. So D came here, A came here, then you gave B a negative and C a negative value. This is how we found an inverse for a 2 by 2 matrix. We did use the determinant in the denominator. Notice that we are using this concept here for these 3 questions, but we're not finding an inverse. It's just saying find the determinant. So we stop here at these 3 independent solutions. And again, let's take a look here. The determinant of a 1 by 1 is defined simply as the entry of the matrix. So if I had a matrix is equal to just one element, negative 2, then the determinant is negative 2. So keep that in mind, okay? Okay, so what to do for a 3 by 3? And we're not going to use the minors or cofactors method. We're going to use diagonals. So let's write that in, diagonals. Okay. Okay, so the first thing we want to do is we want to take the first 2 columns and we're going to duplicate them to the right side of that matrix like this. Okay, so once we duplicate these 2 columns to the right of the matrix, then we're going to take diagonals starting at the top left, working our way to the bottom right. So I'm going to create a total of 3 diagonals like this. And I'm going to multiply straight down those diagonals. So 0 times negative 1 times 1 is 0. Then we're going to add it to the next diagonal product. 2 times 2 is 4 times 2. No, that's times 4. So 4 times 4 is 16. And then I have 1 times 3 times 0 is 0. After we do that, then we're going to take 3 more diagonals. And this time we're going to take the diagonals from the bottom left to the top right. So here's 1, 2, 3. And I'm going to subtract the sum of those diagonals also. So I'm going to multiply straight down those diagonals. So 4 times negative 1 is negative 4 times 1 is negative 4. So the first one is negative 4 plus 0 times 2 times 0 is 0 plus 1 times 3 times 2 is 6. So it's minus the sum, or if you want to, you could distribute that negative out, and it could be plus, 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 minus, 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 right? Or you could subtract, keep it grouped, and add these, okay? Then we want to go ahead and we want to simplify it. So I have 0 plus 16 plus 0 is 16 minus, and I have negative 4 plus 6 is 2. So I have 16 minus 2. The determinant value is 14 for this 3 by 3. Okay, so now we're actually going to use the determinants to apply it specifically to solving a system. And we're going to talk about solving a 2-variable system of equations using Cramer's rule. Okay, so we're going to use Cramer's rule, which says if we take the determinant values and create ratios, we can solve for x and we can solve for y. And that's what this is saying. Let's take a look at our first example. So the first thing I want to do is set up a coefficient matrix, and we're going to call our coefficient matrix D. Our coefficient matrix then is 4, -2, 3, -5. And I'm going to find the determinant value. So the determinant value here is going to be 4 times -5 minus -2 times 3. So this is -20 minus -6, and that gives us -14. Once we have D, the next thing we want to do is we want to find what we're going to call dx. And we're going to find dy. So let's actually do those independent here. Dx and dy. And I find dx and dy, that matrix, by taking this answer column, this 10 and 11, right here, the answer column, the 10 and 11, and we're going to substitute first into the x column for dx. So that 10 and that 11 are going to go into the x column. Everything else in matrix D stays the same, -2, -5. Then for dy, the answer column is going to go into the y column of matrix D. So that's going to be, instead of -2, -5, it's going to be 10 and 11. Everything else in matrix D stays the same, 4, 3. Then we're going to find the determinant values of dx and dy. Okay? So I'm going to have 10 times -5 minus -2 times 11. So here I get -50 minus -22. And that gives us -28. So we're going to do the same thing for dy. We're going to find the determinant value. So 4 times 11 minus 3 times 10. So here we have 44 minus 30 is 14. So according to Cramer's rule, if I take the ratios of dx over d, I will end up with what the value of x is. And for y, if I take dy over d, I will end up with what the value is for y. So dx, we already solved for that one. We said that was -28. And d, we said, was -14. So when I simplify that, I'm going to get the solution as 2. Good. I'm going to do the same thing for y. dy, our ratio was 14. And for d, we got -14. So my solution is? Good. So the solution to the system then is 2, 1. 2, -1. And then I want to make sure that I plug it back in to the given and that it works out. So go ahead, check it. And the solution does work out in the given. If we get a determinant value here for d to be 0, that's going to be undefined. So therefore, we can't have that when we're using Cramer's rule, right? Even though when we were looking at our previous section, we could have a determinant value of 0. But here, that won't work out. And this is the 0 concept we just talked about. So go ahead, pause this video, and try this example as well. So this is what your answer should look like. We went ahead, we found matrix D. Remember that that's your coefficient matrix. Find your diagonals, subtract them. We get -7 for D. Then for dx, you take your answer column that goes here for dx, here for dy in matrix D. Find your determinant values, and we get this. Okay. Then find your ratios in order to find x and y, and our answer is 4, 7. Okay. So now we're going to apply Cramer's rule to a 3x3 matrix. So let's go ahead and create our coefficient matrix. So the coefficient matrix for D is going to be -2, 3, -5, 4, -1, 1, -1, -4, 6. Procedure's still the same. I still want to find those determinant values. Remember, for a 3x3, we do that just a little bit different. okay? And x is still dx over d, y is still dy over d, but now we have z because I have a third column here. So I'm going to have dz over d is going to be z. So remember, when we're finding the determinant for a 3 by 3, we're going to duplicate columns 1 and 2 to the right of this matrix. So that's going to be -2, 3, 4, -1, -1, -4, and I'm going to find the diagonals. So I'm going to take the product of these. So -2 times -1 is +2 times 6 is 12. Our next diagonal is going to be plus -3. And our next diagonal we have positive, and we have 5 times 4 is 20, times 4 is 80. Minus, and now we're going to do the diagonals in the opposite direction. So here I have -5 plus, here I have +8 plus, here I have 6 times 4 times 3, or 4 times 3 is 12, times 6, 72. And I'm going to go ahead and simplify that now. And we end up with a ratio of 14 for matrix D. So now I'm going to find dx. Remember, I'm going to take that answer column that I have up here, which is -11, -3, 15, and we're going to put it into the first column, the x column, -11, -3, +15. Everything else from the matrix D, or coefficient matrix that we wrote up here, is the same. So that 3, -5, -1, 1, -4, 6 don't change. And now we're going to do what we did before. We're going to duplicate these two columns to the right and find our diagonals. So go ahead, find the determinant for dx, and then pause the video. And so for dx, we get -14 after we go ahead and work that all the way through. So in order to find x, I'm going to take my ratio dx over d. dx we have -14, d we have 14, so x equals -1. We're going to go ahead and do the same thing for y. So for dy, now we're going to take our answer column, that -11, -3, and 15, and it's going to go in the middle of matrix D. So matrix D was -2, 4, -1. Now we take our answer column and it goes into the y column, -11, -3, 15, and then everything else for matrix D is the same. So that's going to be -5, 1, 6, and now we're going to find the determinant of this matrix here. So go ahead, pause the video, and solve. Okay. So here's y completely worked out. We went ahead, we found our determinant for dy, and we got 56. Then we took our ratios and we found that y equals 4. So we're going to go ahead and do the same thing for z. So substitute your answer column into the z column, pause, and try. Okay. So here's a complete solution. When you find the determinant for dz, you're going to get 70, and then remember to take the ratio. You're going to get what z equals. Make sure you take the complete solution and check it in the given, and it does work out.